In this lecture, we are going to discuss about attenuation. Attenuation, we have already described it, like we have already derived that attenuation is half of power lost per unit length by power transmitted. Now, our basic aim is to determine what is the power lost per unit length and what is power transmitted for each case, TE, TEM and TM. We have derived what are EY, HX and HZ. These I have noted them here for easy reference. 1, 2 and 3 are the equations. Now I have noted JSY is to calculate the power lost per unit length. To calculate power lost per unit length, I am taking the concept of surface charge density. So, after deriving the surface charge density from the equations, then I'll club it with the surface resistance, and then you can derive what is power loss per unit length. Now, in the case of TE waves, the JSY, we always take modulus, that is equal to Hz. That is the you can write the magnitude of Hz. That is, this J part is gone. That is magnitude of J m pi by omega mu A is m pi by mu A, omega mu A. Here we also have C1. So C1. Now power lost can be written as half into surface charge density into surface resistance. That is this is surface resistance as we know. That is Rs is equal to root of omega mu by 2 sigma. This is, we are substituting it here. Half into this particular part into root over this. This is Rs. This area is always written as dA into dy. That is, we want surface charge density per unit length. Now we also calculate power transmitted as half into real part of E into H conjugate. Previously, while deriving the attenuation, we noted that is half into V naught I star. The same thing is written here. Z component, because it is traveling in the Z direction. Propagation direction we usually mention, because power transmitted is always a vector. That is, you can write it like this. Now power transmitted is half into real part of E into H conjugate into J bar. Now how do you write, how I have written minus for this? Because I have EY, HZ, HX as my components, I have used HZ to derive the power lost. So take off this. And now you have EY and HX components. Now you know the notation X, Y, Z. When you multiply X into Y, you get a positive direction, that is plus sign. But when you multiply Y into X, you write a minus sign. Because you are cross multiplying EY and HX, you are writing a minus sign, minus half EY HX. But if you would have multiplied EX cross HY, then you should have written EX into HY. So you usually multiply EY HX and you get this result. We have derived the attenuation for TE wave, and now we have to derive it for TEM wave, where we have only HY and EZ. Now you take the components, and the surface charge density is, always the surface charge density should be in terms of H field only. Here the only H field is HY. So the magnitude of HY is C4. Now power lost when you are calculating, the same as before, half into JS square RS. That is half into C4 into RS. RS I have told, it is root over omega mu m by 2 sigma m. I am writing B also here so as to indicate it is per length. Now the power transmitted is half into real part of E into H conjugate. That is half into eta. The only components here are, we have only HY and EZ. X, Y, Z. You are multiplying Z and X. That is similar in clockwise direction only, so you get positive sign. If you would have multiplied E, X and H, Z, then the multiplication is like this. So now in this case, that is half into eta C4 square. That is, you get this relation. Now for attenuation, you write power transmitted by, because you have two plates and this power loss is only for one plate. You have two plates in a parallel plate waveguide, x equal to 0 and x equal to a. So alpha is equal to power transmitted, power loss by 2 into half of this part. Half of this part. So this two get cancelled and this C4 square get cancelled, B cancels and RS by sigma A. Here I forgot to say B and A are the dimensions of the plate. So A is the distance between the plates. This is, as we are indicating, x equal to A and 0, the distance between them is A, and that is this A. Eta is efficiency, that is wave, it is wave impedance. So alpha is 1 by eta A into root over omega mu m by 2 into sigma m equal to R by 2Z. Alpha is equal to 1 by eta A into root over omega mu m by 2 sigma m. Alpha is equal to R by 2Z0. This is impedance.